Lesson 82, solving multi-step compound inequalities. So just as a review, we've had conjunctions, which are compound inequalities. Conjunctions, remember, they have the keyword and they have common solutions. And then there's disjunctions, where the two inequalities have no common solutions. So they use the keyword or. So let's take a look at our first type of example here. Here's a solving graph. We have two multi-step inequalities to solve. This one is a disjunction because it has a keyword or in it. So let's do one inequality first. So I need to get 4x by itself, so I'm going to add 7 to both sides. And I have 4x is less than 10. To get x by itself, I divide by 4 on both sides. And I have x is less than, and I can simplify this by 2 halves, and that would give me 5 halves. And bring down my keyword, so or, and on to the side, I add 19 to both sides, and I have 2x is greater than 12. The x by itself, I divide by 2, and I have x is greater than 6. So now on my number line, we go from 2.5 to 6. So I'm going to have this as 2, 3, 4, 5, 6. And then we have an open circle on 2.5. So 2.5 would be about here. It's got to be less than that, so it goes to the left. And then an open circle on 6. It's got to be greater than 6, so it goes to the right. That would be our inequality with our graph. Next one, -9 is less than or equal to 3x minus 4 plus 2x is less than or equal to 11. This is a conjunction inequality, and I know that because the variable is in the middle of the two inequalities, so it's combined. So now I need to combine my x's in the inside, so 3x plus 2x is 5x minus 4, and then that's less than or equal to 11, but it's greater than or equal to a -9. From this point, now I need to get the 5x by itself. So I'm going to add 4 to the inside and to the outsides, and I have a -5 is less than or equal to 5x, which is less than or equal to 15. And then to get x completely by itself, I divide by 5 on the inside and the outside. And I'm left with -1 is less than or equal to x, which is less than or equal to 3. Now I can draw my number line. It goes from -1 to 3. So -1, 0, 1, 2, 3. And I need a filled in circle on -1. It's greater than -1, so it goes to the right. And a filled in circle on 3. It's got the equal to part, so it's got to be less than, so it goes to the left. So they combine, so they have common solutions. Next examples. Here we have a keyword or, so it's a disjunction. So we do each one separate. So I need to get the 2x by itself by subtracting 9 on both sides. And I get 2x is less than a -1. To get x by itself, I divide by 2. And I'm left with x is less than half, -1/2. And bring my keyword down or. To get 3x by itself in the second one, I subtract 3 on both sides. And I get 3x is greater than 9. To get x by itself, I divide by 3. And I'm left with x is greater than 3. And then I can draw my number line. I'm going from -1/2 to 3. So I'm going to have -1, 0, 1, 2, and 3. Need a open circle on -half, which would be right here. It's got to be less than half, -half, so it has to go to the left. And then I need an open circle on 3. It's got to be greater than it, so it goes to the right. Our next example here, the conjunction, because the variable's in the middle. So to get x by itself, 2x by itself, I'm going to subtract 8 on the inside and the outside. And I'm left with 16 is less than or equal to 2x, which is less than 30, that'd be 28. To get x by itself, I divide by 2 on the inside and the outside. And I'm left with 8 is less than or equal to x, which is less than 14. Now my number line go from 8 to 14. So 9, 10, 11, 12, 13, and then 14. Need a filled in circle on 8. It's greater than 8, so it goes to the right. Open circle on 14. It's less than 14, so it goes to the left. The second type of problem, we need to simplify before solving the inequalities. So in this first one, we need to distribute. So distribute the 3. So I'll have a -15 is less than or equal to 6x minus 3, which is less than or equal to 39. From this point, to get 6x by itself, I add 3 to the inside and to the outside. I'm left with a -12 is less than or equal to 6x, which is less than or equal to 42. To get x completely by itself, I divide by 6 on the inside and on the outsides. And I'm left with -2 is less than or equal to x, which is less than or equal to 7. And then draw my number line. Actually, this one they didn't actually have us graphing it. We don't have to worry about graphing. This would just be our answer. Next one, we have a disjunction, because that has a keyword or right here. So to get -6b by itself, I add 18 to both sides. And I'm left with 6 is greater than or equal to a -6b. Get b by itself, I divide by -6. Because I'm dividing by a negative number, I need to flip the symbol. And so b is now greater than or equal to a -1. Then bring down our keyword or. And we have distributes here. So that would give us a -8 plus 2b is greater than or equal to 10. To get 2b by itself, I need to add 8 to both sides. And I'm left with 2b is greater than or equal to 18. And to get b by itself, divide by 2 on both sides. And I'm left with b is greater than or equal to 9. Moving on to the next example, you distribute the 2 here. So you have 6 is less than or equal to 2x plus 24, which is less than 12. To get 2x by itself, I need to subtract 24 on the inside and on the outsides. I'm left with a -18 is less than or equal to 2x, which is less than -12. To get x by itself, I divide by 2 on the inside and the outside. I'm left with -9 is less than or equal to x, which is less than -6. And this would be our compound inequality as our answer. Next one with this disjunction, distribute the 2. I have and negative 16 is greater than 2x minus 4. To get x by itself, need to add 4 to both sides. I'm left with negative 12 is greater than 2x. To get x by itself, I divide by 2. And I have negative 6 is greater than x, or on the other side, need to distribute to 3. So we have 27 is less than 3x plus 6. To get 3x by itself, I subtract 6. And I'm left with 21 is less than 3x. To get x by itself, I divide by 3. I'm left with 7 is less than x. This would be our inequality. And some application problems here. The zoologists randomly choose 5 zebras out of a herd of 20. 4 zebras weigh 540 pounds, 550 pounds, 520 pounds, and 530 pounds, respectively. What could the weight of the 5th zebra be if the average weight of all 5 zebras is to be between 500 and 600 pounds? So 5 zebras out of the 20, so you have, let's write our inequality. We have the weight of 540 plus the 550 plus the 520 plus the 530 plus the 5th one. We're just going to call that one n. But since they said they're looking at the average weight, average means you add them all up, divide by how many zebras, which would be 5. And it has to be between 500 and 600 pounds. So on the high end, it has to be 600 pounds. So it cannot be more than 600. And on the low end, it has to be more than 5. It has to be 500 or more. So I put the 500 here. So the first step, I don't want this fraction in here. So I'm going to get rid of this 5 by multiplying this middle piece by 5. And when I do that, the 5s divide out, and that's just a 1. But whatever I do on one side, I have to do on all the other sides. So I multiply by 5 on the outer edge. So this would be 2,500, which is less than or equal to. And then the inside, I'm going to add those all up. So 540 plus 550 plus 520 plus 530 gives me 2,140 plus the 5th zebra. Has to be less than or equal to 600 times 5 would be 3,000. Now to get to n by itself, I need to subtract 3,140 on all the sides. So 2,500 minus 2,140 gives us 360 pounds. And on the other side, we have 3,000 minus 2,140 gives us 860 pounds. So the 5th zebra has to weigh anywhere between 360 and 860 pounds. And our last one here. Of 4 babies born in a hospital in one night, 3 have weights of 5.2 pounds, 6.3 pounds, and 7.5 pounds respectively. What could be the weight of the 4th baby if the average of all their weights fall within 6 and 8 pounds? So we're going to write our inequality just like we did our last one, but here we're just going to simplify first. So we're going to have 5.2 plus 6.3 plus 7.5. That adds up to 19. So 3 of the babies' total weight is 19 pounds, plus we'll do W for the 4th baby, and it has to be between 6 and 8 pounds. So it can't be more than 8 pounds, and it can't be less than 6 pounds. But it can equal 6 and it can equal 8, but it just can't be lower than 6 or higher than 8. Now to get 19 w by itself, I subtract 19 on both sides. Actually, before I do that, since we have to find the weight, or the average has to be between those, so I have to divide this by 4. So I have 4 babies, the weights, and now to get rid of the 4, I multiply all the sides by 4. And on the inside, 4 divided by 4 is 1, and I'm left with 19 plus w is less than or equal to 32 on the right-hand side and 24 on the left-hand side. Now I subtract 19 to get w by itself, and I'm left with 24 minus 19 would be 5, which is less than or equal to the w, which is less than or equal to 32 minus 19 is 13. So the fourth baby has to weigh between 5 and 13 pounds. So that is our lesson today on solving multi-step compound inequalities.